just a little bit of a powder, a little bit shine on your face. Okay.
You're right.
Now we can record.
Okay, we are good now.
Chale, I think we have like 14 folks and we have a hard stop
Okay.
at in 58 minutes. So maybe we can kick it off. So Naveed bhai, if you don't mind, if you can just set up like the goal of this group. I'm just executing on your behalf, but it's your idea and stuff. So if you don't mind,
So
if you
can I share my screen?
yeah, give me 1 second if I haven't made you.
So I'm going to really struggle with sharing screens like that because for a very obvious reason, because I almost never do that. And because somebody else is doing for me.
Depends on what you're going to share, Naveed. I've also, for some reason, I became a co-host. I also can share, I think. So if it's something I can share on my end that you know.
No, it's actually, I just made some slides. I just wanted to introduce the program. So
please go ahead.
Okay. Host disabled steering sharing. So I say host disabled participant screen sharing.
So Ali bhai, if you could allow the screen sharing, please. Or make
yeah, he's not. Try it again, Naveed.
Okay, all right. Now we have. All right. Okay. So I'm assuming everybody can hear me. I just want to talk about this program that I think a lot of WhatsApp messages are going around, but I thought the way we go about doing it, since we have many different universities here, why don't we have Ali Fahad introduce the champions that we have for the university, and for each university, if each university can take 1 minute to introduce their professor, then maybe 1 minute about what they have done in last 1 year in microelectronics. It'll get everybody introduced, and then I will talk about the program.
Yeah, absolutely.
Which university should we start with?
I think we can start with NED first. Like, is there anyone here from NED? If you want to.
Assalamu alaikum. I am Fahim Haq. My PhD research was in RF transceiver design. In particularly, I am specialized in all digital transmitters. My area of specializations are power amplifier, transceiver designs, and all digital transceivers. Currently, I am working on all digital transceivers, how to go for an all digital transceivers where there is no ADCs and DECs.
Okay. Anybody else from NED?
Yes, Assalamu alaikum. I'm Hamid Khan. I am also a faculty member at the Electronic Engineering Department, and I'm the one responsible for the Electronics Design Center and the Cadence Design Suite at NED University. My area of expertise is also RF power amplifier designs, and I have worked on CMOS RF power amplifiers in my PhD and designed switching mode power amplifiers for 3G and 4G communication. And I've been active in designing of these power amplifiers since 2008.
That's excellent.
Thank you,
Anyone else from NED?
I believe there are only 2 of us from NED.
Challenge say. Second, I think would be like LUMS. I'm just going through the university that I've written. So LUMS ke kaun hai yahan pe? If you can just come off mute and just introduce yourself. So no one from LUMS. Okay. So anyone from GIK? So what we're asking here is if you can come off mute, because I do see some names here from GIK. So maybe I'm If you can't hear me, just let me know.
Assalamualaikum, Ali. Can you hear me?
Gigi, I can hear you.
Acha. Urdu is fine, I guess. Or...
Gigi, any language. Any language.
No,
Okay.
Muhammad
Really?
doesn't understand Urdu. So Muhammad is, I think,
Oh.
probably English would be better.
Okay, English will be.
Oh, okay. Yeah, that's what I was asking. That's fine. Dr. Naveed here. Ali is my batchmate. Sorry, I was just trying to find how to unmute on my mobile. So I'm joining from Faculty of Engineering Sciences at GIK. We have at the faculty multiple streams. One of them is semiconductors and microelectronics. I think because of that, we are quite a bit relevant to this project. My own work is not done.
I think we lost him.
Dr. Usman. Can you still hear me?
Yeah, I think now I can hear you. Yeah.
Okay. Yeah, so we have two faculty members in this group. I think both of them are traveling today, so maybe they could be a bit late in joining. We will see. But at GIK Institute, we do have facilities in materials department and EE in IC design, and we are very much interested in looking into the prospects of this proposed project. Thank you.
Thanks.
So we can go to NUST next. Is anyone here from NUST?
Yes, I think Sir Hamad Chima is from NUST.
Yes, Assalamu alaikum everyone. This is Dr. Hamad Chiman. Good to be a part of this team. So at NUST, we have 4 to 5 faculty members related to IC design. And initially, we had been offering kind of courses under the electrical engineering, specializations separately. But lately, in February, quite recently, in February 2020, we have got a specialized stream approved from NUST, which is focused on IC design. So it's called Integrated Circuits and Systems. And the first batch of this specialization would be starting in fall 2021 from September this year. So this basically stream will have courses only in the IC design spectrum, covering digital, mixed signal, analog, and RF as well. So 8 courses in that stream. And we are actually headhunting for faculty members at the moment. It's open. The faculty positions are open, and I can share the ads with you. So I would also like if you can share it in your circle, so we can get someone from the expats who are maybe moving back to Pakistan. As far as the work is concerned, we have tools, first of all, available. We have Cadence license, and we have Keysight, whole suite available, 52 licenses of Keysight, as well as Cadence full suite, at the moment 5 licenses. Access to PDKs is also available. We have TSMC PDKs, as well as PDKs from IHP Germany, and some RF PDKs from Wolfspeed and Win Semiconductors, which basically are known for gallium nitride technology. Personally, I have a PhD in analog and RFIC design from Eindhoven University of Technology in the Netherlands. So my PhD was in 60 gigahertz phase lock loops, and this work was done with Philips Research. So the idea, we in Pakistan, that we have been in this chicken and egg issue, where there's lack of industry, due to which there are no academic programs, and due to lack of the academic programs, we don't have that HR to bring in the industry. So we are, trying to address this academic side of things with this dedicated program, and then hopefully kickstart, let's say, the industry to come in. In parallel, I would also like to mention that is a faculty member, Dr. Rehan, at School of Electrical Engineering at SEEKS, who heads a lab, which is also called RISC, but it stands for real time something, not the RISC we know, but he works on RISC 5. And Alhamdulillah, he has been working in this area for last 3 years, and he has a 32-bit microprocessor soft IP developed, and we are going towards its silicon version, inshallah, in this fall. So that processor is actually built from really bottom up. So it's bare bone structure, no existing open source cores being used. So it's like RTL written ourselves. So this is the state we are in. In parallel, we have done.
Ahmad bhai, I'm really sorry to cut you off, but we literally have a hard stop in like 47 minutes. And we have like a lot of other schools to go through and a lot of things to cover. So I'm
okay.
Apologies for jumping in, but
No problem.
we
Sorry,
just
I'm
have to make sure. No, sounds. Oh, thank you so much for joining. Anyone else from NUST?
I'm not sure if there is someone else from NUST.
Okay. Anyone from FAST?
We got a lot of messages from Dr. Rashid. He cannot join, but obviously he has a pretty decent program in microelectronics. So yeah, they will definitely join the program, but he's not available today.
Okay, sounds great. Or Hassan Saif, are you from FAST?
Assalamu alaikum. Yes, I'm Dr. Sansef from FAST.
Okay. Can you just quickly share your interest?
Sir Rahil, am I audible?
Yeah, we can hear you.
I'm Dr. Sansef from FAST. I'm working in coordination with Dr. Rashid Ramzan. And at the FAST, we have the facilities of the cadence tools. And we have the license for the 10 cadence tools and install all of the cadence tools and the 65 nanometer PDK from the TSMC. And currently we have the batch of the MS student from the NICA at our university that are participating for the MS program, and currently we are in the third semester of the MS program, and we have covered all of the aspects of the design, and we have developed all of the, in addition to the formal course for the MS, we have developed some labs for the cadence to make students introduced to the new tools, all of these steps.
Okay, thank you so much. So there were some
I
other.
am at my hometown, and here the net is quite broken.
Okay, thank you so much. Anyone else from FAST? Okay, I know we had some other schools like Usman Institute and PAF. Are there any other universities that we did not cover here?
Qaid-e-Azam University, I can see Dr. Arshad from there. And maybe ComStats. Somebody from ComStats.
Hello, Assalamu alaikum. Hello, Assalamu alaikum. Dr. Arshad Hussain from Kaiju University. Can you hear me?
Ji, we can hear you.
Yes, we can.
Yeah, I'm Dr. Arshad Hussain from Kaiju University. My specialized area is oversampling data converter. So I have already built up a lab here in Kaiju University Electronics Department. So we are basically developing SAR ADC at the transistor level and going toward now the layout level. So we are because we don't have a tool, so register tool, so we're just using a crack cadence for the startup of this thing. So I have around 12 undergraduate students, 7 master students, and 1 of the PhD students in our lab, system on a chip lab. Hello.
Hello,
Can
Ji,
you
we
hear
can
me?
hear you, Ji. I think
Thank you, sir. Thank you very much.
So much. Okay. Anyone else from any other school? Like I think ComStats, yeah, PF, any other university here?
I think I see Ali from UoIT.
Yes, this is Ali from Smart Institute of Technology. So actually, we are undergraduate school in Karachi, and we are teaching Risk 5 in our undergraduate course. And also, at the last December, we have taped out using Google Open Shuttle process with the Efablis, our two SOCs, Ghazi and also Ibtida. So Muhammad knows us. We work with them. So our pedagogy of learning things are different. We worked on undergraduate level, starting early with the students. So both the tape outs are coming from the students. So yeah, we are working on the RISC-V 32-bit processors, and also exploring other open source, just like the open source FPGA and things like this. So yeah, we are really interested in the program. Whatever we can do with that. Yeah, thank you.
And of course, Ali, we remain your big fans. So all the power to you.
Thank you, sir. Thank you. So nice of you.
So just the last call. And any other university here? And I know we have the names. And maybe at the end, if you guys don't mind, if you can just share your email in the chat, so we can write that down and we can reach out to you after the session. I think it will just make it easier instead of doing it on WhatsApp. So I think over to you, Naveed.
All right. Okay. So I think I would like to spend very little time and then give at least 10 minutes to Muhammad to give us an introduction. Still, hopefully have 10 minutes in the end for question and answer. So here's how it goes. So it's very simple. The idea was, how do we kickstart the microelectronics in any particular country? So we came up with this, what we call, me, Muhammad, and many other people have been thinking about, is what can we do? So I think the idea really was, we needed somebody to sponsor something. So we are all part of this open source FPGA foundation. So we said, let's start there. So we said, let's call this program something. So we call this program Tape Out World. What does it really mean? It's a non-profit program. And the only single purpose is democracy of silicon. The idea is, let's go out, reach out to as many schools as possible, get them trained, promote design, manufacture of prototype FPGAs, but that's kind of the charter of the foundation. But obviously there would be CPUs and other chips. We don't really care. People are doing more and more chips, and primary targets are universities in countries where normally chips are not being taped out. So that's kind of the general idea of what we call tape out work, right? So if you look at, there is a tape out committee inside the Open FPGA, and they are following tasks. Their first job is to go identify countries where such a program would be needed. Let's start with Pakistan. Let's start with Egypt, Turkey, Bangladesh. Then what we want to do is to identify a country champion. Like in our case, it turns out to be Ali Fahd. So a person who is so motivated, is going to run around, is going to get everybody organized. And so we need somebody like that. Third, we will arrange training through our own education and training committee in the Open FPGA Foundation. And we have partners like VSD, Redwood EDA, and others. And then we also provide tape out capabilities through Efablis and help facilitate that as much as we can. So the idea is very simple. Identify a country where not as much activities are going on, get that, more schools enrolled in this program, and get more and more of them, somehow get them training and get them going, right? It's a very simple program at the highest level. So what do we want a country champion to do? It's very simple. That person, we want to identify for every country a person who's going to go around and do one thing: identify universities in that country, and then identify university champions. And once that is done, then he holds kind of team meetings between these university champions. And then the idea really is that add more and more university champions as the program matures. So what is the role of a university champion? And we have several university champions here. So for their first role is, do we have 2 professors in this university at least who are interested in microelectronics? Do they have a microelectronics program? If they are trying to establish one, can we help them establish a program if they don't have one? How do you do that? Well, as you can see, there are many universities who already have established programs. In each country, that's the case. It's a case of just connecting them together and giving them more support and things like that. So if there is no program, get that stuff. And the second important task of the university champion is to identify some source of funding. In particular, we don't want to really burden the university. That's not approach. Universities are already overburdened. We cannot go to a program and say, okay, why don't you fund this tape out? They will not be able to do it. The idea really is to work with alumni organizations. They are very highly motivated. They want to do something. It is not a very big raise. It's a smaller raise. And this is potentially they can help with. And that is the idea that we came up with. Let's reach through the alumni organization, see if they can fund it. What is the program? It's pretty simple. The idea is to, since we are identifying two professors, identify two particular tape outs that we can deal with them. Each tape out is around 9,500. So total program per university will be 19,000. And what else we will do is that we will also provide specific trainings, tape out process and things like that. That's what Efablis will do.
Sir, a quick question over here. So this is 19,000 one time or 19,000 for every program? Per year or something?
Yeah, it's only this is for 9,500 per chip. So every time you do a chip, it costs you 9,500. So we are thinking per year, we are doing two chips, so it's 19,000 per year. But we have other sources of funding. We just want to get it started. Okay, and I'll talk more about it. But the idea was that let's get it started and let's see how it goes. And then we'll see how we can sustain it over the coming years. But right now, it's a matter of just getting something kick-started, all right? Then the role of FPGA Foundation would be to provide as much training as possible. There are two kinds of training. They'll provide webinars mostly on FPGA design. So we are doing the first one on 14th of May. All of you are very welcome to attend, register. And that will tell you how to potentially design an FPGA and then whatever is available on GitHub and the process. And the second thing we'll do is we'll provide more design trainings for students. And there will be small cost. And the reason there will be a small cost, maybe like $5 or $10, something like that. And the reason is because we will actually give them FPGAs that they can actually program and things like that. And if they don't have that $5, $10, we'll find a way to get them funded. But the point really is, again, we're not trying to make any money, is to get many more people interested in design and so on and so forth. And the job of the university champion would be to spearhead the fundraising and through the alumni groups. For the NED, we already found somebody to fund it. So we will have the NED program funded. So that 19,000 is raised. So when we kickstarted, in terms of Pakistan, we found out that several universities are already doing it. And people like Osman and others, Osman Institute have already taped out a device. Okay, so using the Google program. So now several people ask the question, what about the Google program? Google program is actually, Google funds a shuttle potentially more than once a year. And the idea is that if you are willing to open source your design, then you can apply for it. And if they select your design, you will be selected, and through Efablis, it will be taped out. The only issue we had was that if you did that, and if people did all the work, and what happens if their design is not selected, or they're not willing to open sources because there's some IP or some patents that university has, and they want to protect that. In that case, they will not be able to use that facility. And then this is the reason we said, it's a low cost, let's fund it ourselves. Now, obviously the people who already have designs, they do not mind open sourcing it, and they can qualify for the Google program. They should do that. Obviously they should do that. We are not saying they should not do that, but obviously because of the restrictions I pointed out, I think it is preference that we control our own destiny. And this is the reason we are trying to go on our own way and use Google only in the cases when we can use it. So initially we started out with 5 universities, and there is very simple criteria. We knew the 2 professors there, so that's one criteria. And secondly, we knew the alumni organization, and we thought they can raise the money. There is no other reason. So for a lot of people ask the question, is there any restriction on any university join? No, zero. Every university in Pakistan, every organization, everybody can join. There is no restriction. And so many people have come forward. The only restriction we do have is that we want to at least have a couple of professors who are working in this area. And second thing is, we want a source of funding, a possibility. And these are the only reason. There is no other reason to restrict anybody. So and plus there is no theoretical limit for any universities to join. If 50 universities came forward and their alumni were able to raise the money, and I'm sure Mohammed will find a way to tape out 100 chips. I think there will be zero issue to tape out the more chips. Okay, so I think there's no upper limit. There's no limit of anybody university joining. It's a matter of making sure we have enough momentum in terms of professors and program, and then we have enough momentum in terms of we can supply them the funding. So our suggestion for the professors is to do one thing is that pick the students. Hopefully they can pick students who have already some training, and then we will help with them, and Efablis will help them with training. And professors help students find projects. Now, this is not the kind of projects the professors were talking about, that they are doing 60 gigahertz, A to D converters and things like that. The purpose of this program is actually to do very simple chips. And what we mean by simple chips is this is to train the students through the tape out process. So what you could do is to actually go on GitHub. There were, potentially 100 plus projects there. You can take some of those projects, look at them, study them, pick up a project there. You can modify it. You can come up with multiple projects, combine them together, take some existing RTL you may have. You might like to tape that out. You can take some FPGA fabric from OpenFPGA, do something with it, but do something simple, something that can be done in a short time. This is not a multiple semester project. This is something simple. The purpose of this program is to give confidence to the students that they can tape out. And then the idea is then we can build on top of that. In terms of the next steps, before I hand it over to Mohammed, I would like professors to identify students who are interested in this, and then help them identify projects as we just talked about. And then over the next 3-4 months, they will execute the project. The open source foundation will get the training organized. Whatever training is needed for the students, we'll do that over the next month or so. The university champions, of course, they will be doing the fundraising, and the idea is to do that in this month of May and June. And then as soon as they have done and they're ready to reserve the slot, then they contact Mohammed, and they can reserve their slots hopefully by the end of June, because we are targeting something in September. And then Efablis task could be to organize the training for all the people who are participating in this program in the country, and then educate everyone about the timelines so that they can keep everybody on track, and then provide some help to folks. So this is very, very simple. I want you to give an overview of the program, and I do want you to give 10-15 minutes to Mohammed to give us an overview of people who are not familiar with Efablis, or some people are already familiar. And then we will have plenty of time to ask questions, and how can we go forward, and how we can make this program into a reality.
Sir, one quick question before Mohammed starts.
Yes, sir.
How many students will be involved in one tape out, as a general ballpark number?
I think the ballpark I would say is between 3 to 5.
Okay, thanks.
And we can share among us. I mean, Usman Institute is here, and I think they have published their numbers. And I think future meetings of this group, we can share with each other what have been the experience so far, and how we can learn from each other.
Naveed bhai, may we request, I think you had a slide or two. If you could share that with us, that would be very helpful. Like personally, I would like to do that and run that by our NUST and USA founding team, so that we can make a case for this $19,000 from NUST and USA alumni, so we could help our university back home, NUST.
Yeah, I'll just send this presentation to everybody, right?
Thank you very much.
Okay. So I'm stop sharing, and Mohammed, you can take over.
Great. Well, assalamu alaikum, everyone. So I just want to start. So I'm going to try to do this as quickly as possible. But for those of you who don't know Efablis, or at least let me introduce myself. My name is Mohammed Qasim. I'm the co-founder and the CTO of Efablis. And Efablis is a company that is founded primarily to change how the semiconductor industry is being accessed in the world. It's not limited to any geography. And the idea came initially is similar to the Apple App Store. There's a marketplace that connects developers, designers with the customers. And then in this case, Apple gives everything required to need it for someone to design or develop an app. We do the same for developing a chip. So our goal is to simplify the process of electronics and chip design and make it available and easily accessible to everyone. We just, in a summary, in order to design a chip, you need several things. These several, any one of them that doesn't exist or not in your hand, you don't have the ability to develop a useful design. You can have, if you don't have a customer, you can develop something to test or learn, but if you have it, then there's access, there's commercial momentum behind it. There's also the knowledge, extra knowledge, because there are many domains now in developing a chip. The IP required, EDA, PDKs, and affordable manufacturing. Our goal is to do this, and that's what we did. This in different ways. We started by standard foundries, worked with foundries like Xfab. We obfuscated their technology and PDK in a way that allows you to access that information in 5 minutes in our platform without an NDA. We also obfuscated the IP, the hard IP, that is developed by anybody in a way that is, again, you can use it integrated without disclosing the IP content, but it would be in a context of a chip you integrate or a higher level. We also, that's even before the Skywater activity altogether. When we started, we went and looked at every one of the things that the challenges we had is to the EDA, and the EDA. Currently, the business model, we all know it. It's contractual and it's governed by or steered towards the high-end nodes and focused on that. The software licensing models are very hard to access, and they're not cheap, obviously. And even if you are at a university and you get it through other means, through some sort of academic university program or so, you get it with restrictions that you cannot commercialize the output. So whatever design, I call this the design graveyard. So many designs in some, if you look at the entire design pool that gets developed within universities, there's a percentage of that's actually can be used, but it cannot be used because it's legally developed under license agreements that don't allow commercializations. So we went in the open source world. We assembled, I looked at who did what the right way and made silicon with what tools, simulators, routers, placers, every part of the entire environment. And we assembled that. When we assembled it, we assembled a team as well. So we created a virtual team like this, supporting the different tools, and we shared the vision, and we said we're going to go make it happen. And we worked with companies like Xfab to start with. In a nutshell, I'll be able to share these slides, but there are key things that I will show you. Just the ability to access the entire environment from your browser in 5 minutes with an option for no NDA. You can start designing a real technology, a real process. Because you don't have the IP is not restricted, is not disclosed, it enables like the IP owner to share the IP without fear. So ARM, you can access ARM IP 102 over the records on our platform without talking to ARM or without talking to me. You can just log in and use them. Now they're obfuscated, means that you can simulate them, you can footprint them and put them in a chip, but you can't see the RTL or the back end. So it's simple things if you think about it, but the key part is to assemble all that and put it in one-stop shop. So we developed several chips in a way using the open source tools. All these chips are actually available like on boards and development boards in different ways. And we got a lot of attention on the first one, which was a RISC-V 32-bit microcontroller on an Xfab process. It was immediately picked up looked at by NEC because it's a open source RTL top level and open source core and the resources around the CPU. And so that design led to the spark where because it was done with 100% open source tools, where Google started to look at this and say, it's great, it's cool. I also noticed the development around Skywater, and we had a matchmaking game. That matchmaking game led to a timeline that says, that was started actually in October 2019, where we developed, under the hood, the entire environment, bunch of chips, as well as converted the PDK from just a standard PDK to an open source type of structure. On June 30, 2020, it was released. The Efablis has used additional resources in the open source, the domain open road project, and wrapped it up with everything that makes it more complete and filled all the gaps. We did a lot of the education and publicity, and continues to happen. And we also created several test chips for calibration with different libraries. And that was a beautiful aspect, because even the libraries, for example, came from Oklahoma State University, and some came from Skywater. And so we were able to build a family of chips with different combinations of blocks and types of resources. That was called Strive, and Strive came back up and running. This would be the first ever test chip, or a chip. Well, I would not call it test chip now. I call it test chip now, but it is actually the first 32-bit microcontroller that digital only, that is 100% open source, from software all the way to transistors. We also created Caravelle, which this is a very important component for this project. It's a carrier chip. That carrier chip has resources that are useful for many things, including a logic analyzer that exists on the chip. You have a memory, you have a bus interface, and programmable IOs. And this is also open source, with available with 10 millimeter squares in the middle. All of that was designed, actually, we had full control on designing this to fit within the radical, so to maximize the number, and at the same time have a good space for the users. The example here is that when presented to you, when you pick it up, you actually can drop in and focus on the IP in the middle, that without caring about ESD issues, the integration issues related to the resources and housekeeping on the chip, you focus on the project. Now, for those of you who didn't have a background on the project in the first shuttle, we were overbooked very quickly. We had a spectrum of contributions from all over the world, and also contributions from individuals, all the way to a freshman in college. From the other side, you have IBM employees developing something for Open Power Foundation, and companies like QuickLogic, Efablis, and Western Digital. A lot of involvement. And one important component is that more than half of these people did not design actual silicon chip before, but they were coming from front end or FPGA background, or embedded software development or hardware development. So they had the ability to front end a lot of things and learn about it quickly, but they didn't have that part. One last thing I want to say about this project here, which is one of the Google touches, is that the champion at Google that we work with is saying that we're not, I'm a software guy. I don't know what a DRC is, physical DRC. So I want a compiler that gives me, like a GNU compiler, that gives me a GDS that works. No DRCs, nothing, 100%. Sacrifice a little bit of area, which is against our nature as semiconductor people, coming to compromise area, power, and all these metrics that are targeted towards process entitlement. That was actually one of the key factors, is that for a given process and you change the metrics, you can actually enable a lot more people to access the technology. So around the project, one of as Naveed mentioned, there was a constraint that all the designs are open source, and you cannot be guaranteed a position on the shuttle. So Google keeps their process basically is a little bit unusual. It's a balance between I paid for it, I do get what I get, And also on the other side, I see the process, I see how they select. They select in a way that makes the program successful and visible and can propel more. So it will be open even more later, but there is consciousness behind that. We were asked to, and I will talk about that in just more details later, maybe I'm cover it, is that to provide a commercial version of that. And that commercial version, you don't have to open source the design, and you're guaranteed a location or position on the shuttle. It started this way, and then we started thinking that based on the recommendations and requests from different people, different designers, and we know why. For the low complexity designs, you go or restrict yourself to area and use of the resources as they are. We found that also there, designers that are, and that's naturally we expected, to go all the way to, I need all the area and I need to be able to have access to feed 3 IOs with clean, low capacitance, low loading interface. I will provide the slides, and I'll provide more, the links for it, etc. And Efablis, when you go to the website, you'll be able to see, I don't want to take more time here, but you will find the marketplace. All the IPs in the marketplace are accessible in a way that I can get. There is IPs and there are chips. The chips that you see here are the chips that I'm showing you on the board here. I can actually create a workspace to myself, and then go to my account and workspace, and be able to go literally just access the chip and access the desktop. Like I'm doing all this, as you can see it live from my browser, and I access the desktop to design. Now I had this prepared earlier, so I pulled in the design. You can have you see that Optoscale. I'm showing all that without an NDA for an XFAB chip. Okay, you can do it right there. So that, and then I would be happy to provide more information just in the interest of time. The key part is that there's a marketplace. You provide all the tools on the other side that enables you from a single point of access to enable you to design instantly, and then until you reach the tape out process.
Thank you, Mohammed. Thank you very much. So we have about 15 minutes, but we have to finish, I think, 5 minutes before, because there are other programs also, scheduled. So I think maybe we can have 5-7 minutes for any question, and then we can wrap up with any specific next action items for the various different university champions.
Yes, this is Dr. Hashim from NUST University. I would like to ask a question from Mohammed. Mohammed, excellent presentation, and thank you for briefing us about this. I would like to know, in your first tape out, the first MPW, you also said that there were about 7 analog and RF designs. So are there open source tools available with the PDK support for analog and RF design as well?
So actually, background is actually analog and mixed signal RF, shifted to digital and SoC integration at heart, so in advanced nodes. So I'll tell you, you can design analog designs with aggressive specs on this process using the public tools, the open source tools, and the reason is you're actually designing with a SPICE simulator and SPICE models. So SPICE models are available, and the one thing that I was a little bit uncomfortable with is that there was no Monte Carlo support for the models that were publicly available. So it would just get added. So now I can claim that you can run, do analog designs all the way to successfully with statistical design. And so the tools exist. Now, if you want to go aggressive RF and start thinking, like analyses that are harmonic balance, and you start doing things like that, this is where you start into you need to know where the tools are calibrated, and the more you go in the RF, you actually need to margin and understand how the tools are acting. Now, and so Yes, there are annual tools. We're preparing also some walkthroughs to enable people to just access that on the platform directly without even installation or anything like that.
Okay, that's wonderful, and I think it's up to us to explore further. Thank you very much.
You're welcome.
Any other questions?
We can't hear the speaker if you're speaking. I can hear somebody in the background. I don't know if it's intended to speak.
All right. Okay. So I think let's use the time to wrap up. So I think the key thing, what we are looking for here is this particular program is just to get the action started on student projects. I would not call them research projects, because research projects take long time development, things like that. So I think that takes time. But the idea really is that you have students who have no experience in tape out. I think let's find out this very low cost way of getting some experience while they are working with you on research projects, so that your research project can be risk reduced, because the students already have gone through the tape out flow. They have taped out something, they have chips have come back, they have debugged them, they know the process, things like that. And so from the university champions like Rahil and others, we are basically looking for is, if this is possible, they go back to their alumni groups and see what can be done to help raise the money. We'd like to do that in the next month or so. And that in that way, we can then reserve the slots with Mohammed and give the professors that, they should be getting the students and identifying the projects. So we'd like to do all of that in the next 4 or 5 months. That's the general timeline. The idea really is get some experience to students in about 5 universities, 6 universities. If more alumni groups come up, or we identify more ways of funding this program, my goal was to do at least 10 tape outs from Pakistan, and more if possible. And so that should be our goal. And I think that will get actions kick-started and many people get started. Obviously, there will be others who will do that with the Google Shuttle, and we will help them promote and help them in any way we can. But through this program, my goal is to do at least 10 tape outs, so that at least 10 groups of students in these 5, 6, 7 universities have exposure to tape out process, and then they can be more useful to the professors for research and advanced work and things like that. So my request to the champions, and I think Ali is in touch with all of them, working collaboratively to get the funding going, and whatever I can do, I will absolutely help. I can join your funding calls. I can go talk to any of your individual who might be instrumental in getting the funding done. I'll be more than happy to, as you know, all of you guys know me, I'll be more than happy to do that. But let's make it a goal to at least do, in this program, 10 to 12 or 14 tape outs from Pakistan, and, make it a strong program for Pakistan. And then we can advertise these tape outs and get other people motivated.
Yeah, and just one more thing. Just I did that so everybody would. I posted on the Slack, on the chat, a link to join the Slack space. I created a channel called Tape Out Pakistan. So I would like for all of you to join it, so that at least this team would have a conversation together, and we can see everybody else as well. But for the sake of this forum, you can have it. So please join, follow that link, sign up with your email, and look for the channel Tape Out Pakistan.
And the other thing is that Ali Ahmed just saw a message. You can see his message. He's saying that maybe multiple universities can share a slot. If that is possible, obviously, multiple projects, if you have small projects, and you can share that.
Yeah, I recommend in this case, the collaboration happens together. And then together, we've done that in one case, or actually 2 cases in the previous shuttle, where the teams collaborated, but they submitted one project.
I see. But I think if the best thing that will happen is that all the universities in Pakistan start working together on multiple projects, and I think that itself will make a huge, big difference. The people are not working in isolation. All these 15 universities or 10 universities that we heard from are working together. And I think cross-learning, helping each other, sharing, and I think that will create the ecosystem that we are looking for in Pakistan. So I thank you, all of you, for joining us today. And I have big, big thanks to Pak Launch and Ali Fad and the rest of the gang there for doing this in the last 24, 48 hours. This is an amazing group of young people. I'm very impressed. And I would like to thank them. And I think let's go forward. I know Muhammad is a big, big friend. He has been with us for 20 plus years. I've known him when he was a young guy. Came to me 20 years ago, Naveed, I'm going to do this great thing. And I thought, you are crazy. And well, the one thing I can tell about him that he has never given up the hope. He has been at it for good 15. We have a mutual friend, Dr. Shafi, among us. He's also from Egypt. And again, I'm asking Muhammad to launch a similar program in Egypt. We will do, inshallah, in Turkey, in Bangladesh, other places. I think that will get a lot cross-learning going. So thank you, everyone, for joining today, sharing your time, and Ramazan Mubarak to everybody, and a little bit an advanced Eid Mubarak as well to everybody. Thank you so much.
Thank you. Same to you, Naveed. Thanks, everyone, and looking forward to working with you.
Thanks. Take care. Bye-bye.